When I was a kid, my real passion was music. I was really into rock, lots of Led Zeppelin. My name is Kevin Costello. I wanted to be Jimi Hendrix when I was like 10. That was my goal in life, and as you can see, it didn't really happen. I work in mathematical physics here at the Perimeter Institute. I'm the William Rowan Hamilton Chair. My work is on quantum field theory. Mathematical physics is a very broad term and can mean all kinds of things. Basically, I'm trying to use techniques from math to understand quantum physics better. Myself, I'm interested in understanding quantum field theory using math. If you were a very formal mathematician, you might put me on the wrong side. I'm too corrupted by physics. But coming here, people were much more open to collaborating across this divide. I learned so much talking to the physicists here. It was a huge boost to my career and my research. I wouldn't have been able to do half as much, I think, like staying in the math world. I got interested in physics because when I was doing my PhD, there was a lot of excitement in the pure math community about ideas coming from string theory. So string theorists had made these predictions. There was some sequence of numbers in geometry that mathematicians were interested in computing. It's like how many solutions to certain equations. They could do the first couple of terms, but string theorists give this beautiful formula for all of the terms. And it was totally correct. So that was really intriguing to mathematicians and made a lot of mathematicians interested in going further into understanding physics, and that's how I became interested. The real world is complicated and messy, and I think the kind of things mathematical physicists like to study are like approximations to the real world, which are more accessible. They're kind of cleaner systems. You can, study them exactly. Like as a framework, quantum field theory has been understood for a very long time. It's basically about how elementary particles scatter off each other, and there's a set of well-defined rules for calculating the probabilities of these various scattering processes. The problem is that these computations become just too hard to actually do in practice. So the kind of thing I like to do is define special systems with hidden symmetries where you can do these computations exactly. And hopefully this will give you insight into systems which are not quite as neat and clean. I really enjoy my work. I think the most fun parts are just, collaborating and, you have some idea, you share it with somebody, you develop it together. I think sitting on your own in your office doing calculations can be satisfying when you get the right answer. It can be a little isolating. I think the really fun parts are the collaborations. That's, I think, where Perimeter brings people together from all different areas to do this kind of thing, and that's what makes it really fun. I play in the orchestra here. I used to play the violin in high school, but the problem with the violin is that it sounds nice when you're far away, but when it's right under your ear, it's incredibly piercing, especially high up. So I didn't like that so much. I've played various instruments, and these days I enjoy playing the viola. It's more of a fun diversion. There's patterns in harmony which are similar to patterns you see in math. But I would say they're pretty different for me. Of course, there have been studies saying, you do something in a different area, it helps you, but maybe that's true. I don't know. But for me, it's definitely a fun thing I do on the side.